Okay, so thank you for coming back because weather's so nice, lunch is so great, and I'm afraid that people won't come back for my talk. So there's a few of you. So thank you so much for coming to my talk, and the talk's gonna be very nice and short because I know that after lunch you may feel a bit tired. If I keep babbling for like 40 minutes, you may fall asleep. So I'm gonna keep it quick. But this talk is kind of more kind of beginner's level. So if you are not a beginner, please bear with me. As like imagine you just learn Python and I'm just starting to use Python to write some application and start running some tests. So this is me. Any complaints or any questions, then you can contact me. My DM is open on Twitter. Also, I am now sometimes stream on YouTube. So please, if you want to, if you're curious what I do there, so you can check it out. So I'm Czech. I work for Anaconda right now. So if you have questions about Anaconda, please talk to me or any feedback about anything that we do. I'm very happy to hear you out. Also, I love open source projects. That's like part of why I love like working for Anaconda because we involve in a lot of open source tools that you may or may not use. Also, I love Python community. I organize a lot of events and I have a lot of presence in different events as well. So let's go into our talk. Who use Pytest? Yes, some of you. So I just assume everybody do testing because if you're not doing testing, why are you here? So you use Pytest, some of you. Do you think you know Pytest really well? Like how, do you really just like use it because, everybody was using it? Or do you actually have thought about that? Or why do I use Pytest, right? So first thing is that what makes Pytest popular? Because Pytest is not the only tool that you can use for testing your code. There's other tools available for your Python code in the Python ecosystem. For example, unit tests. Who know about unit tests? Yes, I can see people nodding. Yes, very good. So unit test is basically the battery that were included with when you download Python, right? So it's default. What we call standard library. It comes with Python. So anybody who downloads CPython could probably use it. I'm talking about CPython here. If you use like other version of Python that, for example, MicroPython, that is like more lightweight, then they may not have these kind of things. But for most people who use Python, they would have unit tests. So it's nice because people usually because it's come with Python, people universally understand what you're trying to do here is a modular testing suite that basically, for example, if you do TDD, like test-driven development, then you probably, your starting point may be something like unit tests, right? You just, write something and then you write the test first, you test something, and then you make it pass, right? So that's how you do it. But the thing is that unit test has its downfall as well because it's not that straightforward to use. You have to import it first of all. No matter whether you any test you write, you have to import the module, and then you have to write the class for it. So for someone who is just starting to write Python, writing a class is already something that is quite scary for them. So so it's a bit chicken and egg. It's good that comes together with Python, but then it's a bit scary to use. So that's why Pytest come into the field and become super popular because it's very straightforward. Any test you write with Pytest, you just you can even put it at the same. For example, you have mycode.py, right? You can even put the test in mycode.py. It's not the normal practice, but for beginners, maybe they would do that. Is not stopping them because all you need to do is to add test something for the name of your function. Then when Pytest see that, then it would just like, that's a test, so I'll run it. So it's quite straightforward to use, and most of the people, the test and the code will be separated. So you just, Pytest will just scan through all the files in your test folder, and then whenever it sees test something, they will just run the test, and then for each of them is a test case. So at the end, Pytest will make a report and then say how many of them passes, how many of them fails. so this is, I was sidetracked because I was thinking that, oh, what if you, you write a test case that doesn't do a search like normal test does, right? And you know, Pytest would just we just let it hi yeah, hi. So yeah, so that's Pytest. So sorry, distracted. So this talk is mainly about Pytest extra features because when you use Pytest, well, except the benefit that it's super easy to use, then you may also like use these features to make your test better, make your life much easier when you're writing tests. So so could you name some of the Pytest feature that you know?
Parameterize.
Yes, parameterize. I love that one. What else?
Fixtures.
Fixtures. Yes. So what else? Yes, I think you covered most of the one that I'm going to talk about because like parameterize, one of the things that I really love, because sometimes when we do tests, right, we have to test all of the different scenario. For example, a user may have an input, right? We collect an input from the user. We have to kind of guess what people would do, right? Some people would do crazy things that put something that is like you're not supposed to answer the question. I ask how many people you give me, like, you know, you spell out 1 to me. It's like, you put in the number, you know. So all these crazy things that you have to test, all the test case. So you may end up writing something like this, right? You get like, oh, I would, you know, just test it normally, and then I would test when it is, you know, someone crazy enough to put all cap because they may be super angry, and someone, you know, oh, just put something that's not there, it's supposed to be none. So I have to test all of them. If I just use Pytest without parameterize, right? So I just do like what, you know, what Pytest does, you know, just write the test, you know, as a function, and then you start the name of test, and then you have to name them very creatively because you have to separate all these cases. Parameterize make it much nicer and niche because you can just take out those common factor, right? I have different inputs there, and then there is a different results that I should compare it with, and then I just, you know, put all these variables into you know, variables I can call them when, you know, and it's a decorator. So this thing add pytest.mark parameterize, that is a decorator. You just add it to your test function, and it will just combine the 3 different tests in one here. So the next step to do, of course, is to use hypothesis that another talk covered earlier this morning. And I also gave another talk about hypothesis in the past. So if you want to know, you know, maybe I have it on my YouTube channel. Just find it out. So yeah, like so what's the difference is that parameterize, you have to think about all the test cases yourself. Like I said, you know, user can be very wild sometimes. They put in things that you are not expecting. They put in. So you have to be really creative and create all these test case. For hypothesis, it will find all these edge cases for you because someone already wrote a strategy. So that's the difference. But if you are just starting out, you just start to, oh, actually, I was just starting to use Python and use Pytest. Start parameterize. That's the first step. Next is fixture. So fixture is a very tricky topic. It could be very easy to understand, but at the same time, it could be very complicated. So what is a fixture? So fixture, so I would, most of the time is like, I think about, oh, why would I write a fixture, right? Like, why do I make things complicated? Well, because it helps you out. First of all, the first benefit of using fixture is that it would take some element out from your test, because ideally, right, you write a test, a unit test is a modular test, that it should only test one thing. So if that thing failed, that means that somewhere in your code, that the part that code that test is testing is wrong. That's why you want to like pinpoint one test for one specific thing that is corresponding to your code. So you don't want to have too many uncertainty in your test. You don't want to have like a lot of different, you know, dependencies, and like, you know, you may go through like 10 steps to test one thing, right? Then it would be very difficult to pin down what is going wrong. So for that kind of case, a fixture will help you because it will take those elements. For example, you do 10 steps and then you test your thing. Then maybe you can put those steps into a fixture. Then that thing, then you know that is, you know, if that test failed, then it's just that thing that you're running at the end goes wrong. It's not about the other 10 things that you have done before. It makes the test much cleaner, again, because you kind of organize things a little bit better. You kind of put those other elements away and put it separately, so it kind of much easier to understand instead of like, oh, why this test function is supposed to test this thing, but why you do other 10 things, right? You already put it away, so for people who are maybe maintaining the test or try to rewrite the test in the future, they don't have to look at that 10 things. They just assume that it's done. Also, sometimes, those 10 steps, you may do the same thing for another test. You may just like, oh, at the end it's different by a little bit, but I want to test them separately. So those 10 steps will be the same thing. So you may, instead of writing it again, you may as well put that in a fixture. Something that I found it very, very useful, for example, one thing that I did in the past is that I have to spin up a Docker container, and then I test, that kind of create a server for me, and then I, test the API of talking to that server. So that is a very useful case for it's a very typical case to use fixture, because first of all, if I have 10 tests that test the same Docker container, I don't have to run, spin it up 10 times. I can just use a fixture that I spin it once, and I just like every time just test different API to it. And another thing is that like it will also like if I just spin it once, they will just preserve. It's not like I start from fresh every time, so I have to maybe do that again, like 10 steps again. So it's very, very helpful. Another thing, one step forward, is that, for example, that spinning up the Docker container thing is not just you use it a lot in your own project. If you use it, like you see that, oh, maybe other people will do that as well. For example, let's say Django apps, everybody needs to run the Django apps before they test something. Then maybe you can create an extension for it. So if you put this like fixture away in a separate thing, then people can reuse it, right? You can ship it as a Pytest extension, and then people can reuse that to test for example, that Docker thing. Everybody spin up the same thing, and then they just test the API. Different people can also use it, reuse that thing. So example will be here. This is a very simple, oversimplified example. I'm doing something silly here. So you see that I've already done the parameterize. So it's good, and I write another test. I just want to, maybe save what I've done in the disk, so I would load it back. I want to test if that works fine. So after I save it, do I load it back and it become the same thing again? So who spotted what I can do here? Something duplicated? Yes, so this is exactly the same, right? So it's silly. So that's why I write a fixture. So this is how it looks like a fixture, and now I have a fixture. So I don't have to repeat this the same thing, and I can reuse this. So this is an oversimplified example, but imagine this, instead of just a list, it's your Docker container, then this will be very useful. Okay. So the last thing that nobody mentioned, and maybe people don't find it, sometimes people overlook and they may heard about it but never really pay attention, is to mark xfail. So what does it do? It sounds funny. It's xfail. It's so funny. But imagine you have you're a maintainer of an open source library, and now oh my god, like we have now Python 3.11, and it's great, and I want to write a new feature just for Python 3.11, and so it's only available to 3.11. It will probably not work for 3.10 because it's specifically for 3.11, right? And so if, because your project is probably living on GitHub, let's say, and you use GitHub Action for the CI/CD check, and you can put in like, what Python version you test on your CI/CD pipeline. So I put in 3.11, 3.10, 3.9, etc., etc. But now I have a problem because my new feature, the new test that maybe my new feature will the test that I write is only pass a 3.11, which is like on my computer, and then for the other versions like 3.10, 3.9, and all this, they will fail. And then now you have a big cross on your CI/CD saying like, your test failed, and then you should not merge this new feature and blah blah blah. And it's very annoying. I just like this is supposed to be. It's fine. It's something I knew I add for 3.11 and 3.10, and others should not worry about it. Of course, you can, in your code, hard code it, so it's like, it's like 3.10, then you pass or something. But there's a more neat and straightforward way to do it is to, so how can I skip a test gracefully instead of writing some like kind of exception, try and an exception, then it's probably okay thing is to use mark skip or mark skip if. So what is this magic? So mark skip is basically just tell Pytest to just skip the test, right? Sometimes, for example, again, let's say you're doing TDD again. I don't know why you do, but yeah, you do TDD again, and you kind of planning a new feature. Instead of writing the new feature already, you spend a lot of time writing all the tests and stuff, right? So this is supposed to fail before you add the new feature. But then you kind of, oh, it's 10 p.m. late. I just want to quickly push it in, and I don't want that thing to fail to alert my colleagues and stuff. So you can just skip it. So the CI/CD won't fail the whole test suite, but whenever it go through when it's a skip instead of a cross, a F you have on the report, or so either F is fail, right? Green dot is a pass. So it's not an F or a green dot. It will be a skip, an S, a yellow S, like skipping this test. So of course, it won't be there forever. You will eventually maybe write the new feature and then you won't skip the test. But this is a very nice way of communicating with your team, saying that, oh, I'm skipping this because the reason is it's coming soon. I haven't written the feature yet. That's an example. Another thing is like to use skip if because you're skipping a certain version. So you can write the condition there. This is just showing something below 3.8 it will skip because this is only available for 3.8 or higher. But this is just one thing. You can also check other thing like the OS, whether the operation system is what it intended to be, or other certain condition, external condition that you need to either test it or not test it. So that's skip. Or one step forward, right? You're being more bold, and now instead of skipping the test, I just mark the test is failing. So why do I do that? Like, why do I mark the test that is failing, that I know is failed? Because I want to pass I want to pass the test suite. I don't want to give a big red cross on the CI/CD. I already know why that is failing, and I just want to mark it fail so I can fix it later. To be fixed later. This is just to mark it, right? It's like mark, it's mark. So just to fix it later. It's not like, oh, I will forget about the test. No, don't. For example, known issue, you know that this will fail maybe because you change something in the code, you patch one thing and the other thing fails, sometimes it happens. Then you can kind of, okay, I will fix it later. It's already 10 p.m. or 11 p.m. at night, I will fix it tomorrow. Or you know that there's some kind of, it will fail on some platform, but it's not crucial. You may kind of let it pass for now, and then you will fix it in future versions. That could also happen as well. Let's be realistic. Nothing can always be perfect. So sometimes, if it's not a crucial thing, that's a popular solution. You may want to quickly release a patch, but that is blocking you. Then maybe you would sacrifice this. So, but please state the reason. I'm not like being naughty and teaching you, you can skip all the tests that fails. So please only use it, when you have good reason. It's a very dangerous thing, so don't just take it very lightly. And please state the reason for doing that. So my talk is a bit short. And so let's recap. So it's very quick. Yeah, I should add more example there next time. Like pro tip, what we have covered today. Parameterize is very good. I think it's one of the most popular things because it's super useful for most people. You have to test multiple cases anyway, just combine it. Sometimes you don't realize. Sometimes I remember I was like, contributing to open source and then I write something that, I need to test this and that. And then I got a review and saying like, the maintainer was like, could you please use parameterize? It's kind of ugly, your code. Well, he didn't say that, but I kind of think that, my code is ugly. So double check and, maybe you can improve it by using parameterize. And fixture is, it could more lead to more advanced usage when you kind of, maybe one day you would write an extension for Pytest and, but you can still use it. But the benefit of it would be more like you're sharing some kind of test feature that you have written. Mark xfail, use it with be careful. Don't use it everywhere that people hate you. So just make sure you have good reason, then you can use it. So yeah, last thing I want to do, EuroPython is going to be in July in Prague. It's going to be nice. There's like lots of nice place to do in Prague as well if you want to extend your stay and do a holiday. But CFP is closing soon, I think. So last chance to submit something, and hope to see you there as well. So that's the end of my talk. Thank you so much.